now let's do proofs. All right, so we're going to prove these triangles are congruent, which means we need 3 pairs of corresponding congruent sides, 3 pairs of corresponding congruent angles. So from the diagram, they're giving us side PR is congruent to side, well, this one. Should we call it NM or MN? We're going from the 90-degree angle to this one, 92-degree angle to this one. So we got to go from the 92-degree angle to M. Don't forget your segment symbol. Segment PQ, this side is congruent to this side. Should we call it NQ or QN? Well, P to Q, using vertical angles theorem, we need to go from N to Q. And lastly, they gave us the third side is congruent, third pair of congruent corresponding sides, I should say. So they called it segment RQ, so we have to call it MQ. So that's corresponding appropriately. That's an M. All right, and we know angle P is congruent to angle N. That's given from the picture or definition of congruent angles. Since they have the same measurement, then they're congruent to each other. They also, from the picture, we have PQR. So PQR corresponds to MQN or NQM. So I did that in pink. P first corresponds to N. Q is congruent to Q. R is congruent to M. And that's by the vertical angles theorem, which is theorem 2.6 on your yellow packet. And lastly, angle R is going to be congruent to angle M. Why? Well, we had 2 pairs of corresponding congruent sides, so that means the third pair of angles has to be congruent. So that was theorem 4.3 from yesterday's notes. So we have 3 pairs of sides. We have 1 pair of angles, 1 pair of angles, 1 pair of angles. So there's all 6 things that we need. So therefore, at triangle PQR is congruent to triangle NQM. NQM. By definition of congruent angles, because we showed all 6 corresponding congruent parts are congruent to each other. Next proof. Are these 2 triangles congruent? So they gave us angle ABD is congruent to angle CDB. Whoa, where's my pen? And they gave us angle ADB. ADB is congruent to CBD. They also gave us that side AD is congruent to CB and side AB is congruent to side CD. So how can we get the third set of angles and the third set of sides? So they gave us these pair of 2 congruent angles. So there's a pair of angles and a pair of angles. So here we're going to get the third pair of angles, hopefully, it looks like. And they also gave us 2 pairs of congruent sides. Side AD is congruent to side BD, and side AB is congruent to side CD. That was also given to us. So there's 2 pairs of sides. So how can I get the third pair of sides? Why is side BD congruent to side DB? And it's labeled this way because we're going from the 2 angle marks to the 1 angle mark in this triangle, and then the 2 angle marks to the 1 angle mark in the other triangle. So that's the reflexive property because that side is congruent to itself. So there we got the third set of sides. To get the third set of angles, well, if we have 2 pairs of congruent angles, then the third pair has to be congruent by the third angles theorem, which is theorem 4.3 if you're looking at your yellow theorems packet. So therefore, the 2 triangles are congruent to each other. Triangle ABD corresponds to triangle C, B corresponds to D, and D in this triangle corresponds to B in that triangle. So we have those 2 corresponding congruent triangles. By definition of congruent triangles, because I showed that we have 3 pairs of congruent angles and 3 pairs of congruent sides, all 6 corresponding congruent parts. I have to type in angle C here. And we only have to use one letter to describe these angles because there's no other angle at vertex A and vertex C. All right, moving on. This is the 7th page. So these are some tips to help you do proofs. So if you ever get stuck on like, how can I find another pair of congruent sides, or how can I find another pair of congruent angles, these are your tips and tricks to use to get that pair. So if you know that M is the midpoint of this segment and you're trying to prove these two triangles are congruent, well, if it's the midpoint, we're going to use the definition of a midpoint. So segment KM is going to be congruent to segment LM in this case for how they're corresponding to each other. If you're given segment BD bisects segment AC, that means segment AC is getting cut in half, which means B is the midpoint of segment AC, using the definition of a segment bisector. Then now that you know it's midpoint, you can use the definition of a midpoint to get the congruent sides. And as well as the reflexive property we just saw in those proofs. In this triangle, segment JL, the way these triangles are actually corresponding to each other is segment JL is going to be congruent to segment JL in the other triangle, where sometimes it's like the reverse order, where it would be LJ, like in that last proof we did. Reflexive property also works for angles like it does for sides. If we're trying to prove these two triangles are congruent, AEB and CDB, angle B is congruent to itself in both of those triangles. It's overlapping. You can use the right angle congruency theorem. If you know two angles are right angles, well, then they're congruent to each other by the right angle congruency theorem. You can use angle bisectors. If we know this ray bisects angle ADC, then we know these two angles are congruent to each other. So triangle ADB in the top triangle is congruent to angle CDB in the bottom triangle for how the two triangles are corresponding to each other. And like we saw in the previous theorem, or a proof, sorry, we have vertical angles theorem still. So angle NPL corresponds to what angle in the other triangle? The way they're laid out, it's going to be OPM, OPM, not MPO. So use our alternate interior angles theorem, corresponding angles postulate, alternate exterior angles, consecutive interior angles, all those things are still applicable. So if we're trying to prove angle QTU is this angle, is congruent to what angle in that bottom triangle? So we're told by the diagram that these two lines are parallel. So what angle corresponds to QTU? Well, we're going to use alternate interior angles using this reflexive, or sorry, this oh my gosh, what is that called? Transversal, not transitive property, the transversal line. So this angle is corresponding, well, not corresponding, it's alternate interior angles. So how do we label it for the corresponding congruent angles in the triangles? So QTU corresponds to RSU. So we're ending with U because we know angle U is going to be congruent to angle U using the vertical angles theorem. So if these two lines are parallel, what angle is congruent to angle ABD? ABD is this one. So we're using this transversal. So I know this is my alternate interior angle using transversal BD. So A corresponds to C, D corresponds to B, and then B corresponds to D in the other triangle. And then corresponding angles, if we have these two parallel lines using this transversal, my corresponding angles are congruent. So how do they correspond to each other in the triangles? Angle VSU is congruent to WUT.